All right, welcome back. So section 1.3, we're going to be discussing sampling methods. I have here a completely nondescript, not related to any cinematic universe list of names that we're going to be using for just the purposes of creating different samples. But before we get started, let's think about what it means to sample. So remember, we're talking about grabbing a small, sizable, um, and easy to work with subgroup from a population. So it is important that we think about, before we do anything else, two things. So our sample size, which we usually denote N, is literally how many people or subjects we take from the population for the purposes of our sample. Ideally, we want a large sample size, but not too large. Otherwise, it gets unmanageable. Take an entire population and use that as your sample, and that's what we call a census. So I want to be careful here and to note that, generally speaking, we always want this relationship to hold, where we use capital N for the population size. And if these happen to be equal, then we're talking about a census. But almost never are we talking about a census. We're going to have a sample that is much, much smaller than the population. The other thing to keep in mind is what constitutes a good sampling technique has two parts to it. The first being, is it representative? In other words, are we capturing all the aspects and nuances of the population, right? For instance, in this nondescript, completely not related to a large conglomerate media company franchise, we may be interested in a broad selection of people from a population. And if we were to only pick, say, humans, or only picking um, males, then that wouldn't be representative because we have a wide selection of humans and non-humans, and female and male and non-binary. So we have to be careful about things like that. The other thing is that we need to introduce a notion of randomness. Why? Well, when it comes to randomness, that's going to be a way for us to insert the uh, probabilistic nature of um, selecting at random and getting us a hopefully representative sample with as little effort as possible. So with that, let's get into our different techniques. All right. So the first is um, as simple as can be, which is the simple random sample. Number one, your simple random sample of size n, which you would do by picking your sample size, let's say 5, right? So if n equals 5, then every name or every subject in your population has an equally likely chance of getting selected, right? So you would do this by picking sticks or assigning everybody a number and then picking numbers at random, using a random number generator, for instance, or throwing darts at a board, right? So for instance, let's say we generate some random numbers, and I'm going to do that using a random number generator. You are not seeing me do this on the other computer that I have here next to me. But actually, if you just Google random number generator, Google has a built-in applet for you that you can do this with. Now we have here 15 names on the list. So I'm going to generate 5 of these names. And if I happen to, for instance, accidentally generate the same number, I'm just going to skip it. Okay. So I got 1, 14, 12. See, where would 12 be? Here. Uh, I got 14 again, so we're going to roll again. 6 right here. And we need one more, right? 8. Okay. So we've selected 5 people at random from this list. Now, we're not guaranteed to get a representative list, but it's a good start. So it's good because it's simple. You don't have to think too hard about it. But again, if you're trying to control for a certain variable, it may not be that effective. You'll notice that in this case, we've selected 5 such characters from the nondescript franchise, and only one of them is female. One is non-binary technically, but again, not really that representative of a list, right? Okay, so what other techniques do we have? Well, let's start off. What about what we call a systematic sample? This isn't going to be random, but that's okay sometimes. Systematic refers to we have a system, right? An algorithm. So for instance, I can pick every other name, or I can pick all the names on a diagonal, or I can use a formula, any formula, right? So for instance, let's say I'm going to pick every third name. So let's go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. So it was systematic because there was a pattern, right? Again, the representativeness of this, not guaranteed. Here we have, again, we've got, one non-binary character. We've got a non-human character, but the rest are all male. And, well, again, not the best technique, can introduce some bias. So what other techniques do we have available to us? We can also implement something called a stratified sample. What a stratified sample does is maybe we choose a variable to separate our group, our population, into subgroups, right? So let's say we're going to go with, we're going to go by gender expression, right? So whether they are male, female, non-binary, okay? And I'm going to indicate those with different colors, and then we're going to pick from each of those subgroups, right? This categorization scheme, we might also call it stratification, and then pick from each of those at random, okay? So let's go with so there's first the female characters, of which there are not many, and non-binary characters, which I believe that would be the only one. Yes, that's right. Okay. So let's say we pick one from each, right, at random. Now, this is the difficult part where if you have these subgroups that are of different sizes, for instance, right, we have 3 female characters, 1 non-binary character, and all the rest are male. So that may make it difficult to get a proper selection from each one, but as long as we pick, say, just one from each, then it should be fine, right? Okay, so I'm going to again use a random number generator to pick my sample, one from each group. Okay. Oh, actually. Okay, so I got from the males 4. From the females 1, 2, 3, 4, 5. Okay. And then, well, there's only one way to pick a non-binary character here, and that's Vision. Okay, great. So we have our 3 one from each category. Again, this is a way for us to control for certain variables. There's all sorts of ways of doing this, right? Gender expression, whether they are human or non-human, whether they're alive or deceased. Spoiler alert. All right, so that's stratification. It's effective when, and it goes in tandem with when we discuss our experimental design in the next section. The other thing that we can do is we can collect what we call a cluster sample. A cluster sample works in much the same way, but we're looking at an entire subgroup instead. So rather than saying from each subgroup, we're going to pick, one or the other, we're going to pick from however many subgroups we have, we're going to pick an entire group, right? So let's say I'm going by rows, right? So 1, 2, 3. So in this case, I'm going to pick an entire row based on a random number that I'm generating, right? So let's say, I happen to get the number 1. So this is it. So the benefit here is that it's actually kind of the opposite effect. So rather than controlling for that effect, we're specifically looking to examine only that effect. Of course, in this case, we're just talking about generic rows, but it could be something more important. It could be, for instance, age group, or it could be racial category. The last technique that we're going to use, that we're going to introduce for sampling, is what we call the convenience sample, which has certain subflavors. And unfortunately, it is both the worst and the most common sampling method used. Why? Well, for the reason that one particular kind of convenience sample is something that we call a voluntary response sample. You have almost certainly participated in a voluntary response sample. In fact, I forced you to. Well, not forced. The point is that it's voluntary. You completed a getting to know you survey, and you either chose to do it or didn't do it. Most of you did. And so that is an example of a voluntary response, but that's because you're considered a sample because you're only a certain group of students out of the total student population that's here at ARC. So any poll, survey, um, anything where you as a person have the agency to decide, I'm going to respond or not respond, that's a form of a convenience sample. And that's the best we can do sometimes. That's just how it is, right? You can't force anybody to do something. So for that purpose, right, let's think about what that looks like here, right? So let's say, I'm just gonna pick it at nilly-willy, right? Let's say maybe it's because I'm gonna pick my favorites, right? Or I'm being lazy and I'm just gonna pick like the first 3 or 4, right? So let's say I'm gonna pick 3, right? And I'm just gonna pick them however I want, right? Okay, 1, 2, 3, done, right? So a convenience sample is always done without any consideration to the representativeness, to the um, whether it is random, because it's generally not. It could be, but because it's convenient sample, you're doing it basically as lazily as possible. So for that reason, we have to talk about the bias that each one of these techniques introduces. So we have 2 different kinds of bias. So we have random and non-random sampling bias. What constitutes random versus non-random? Random sampling bias is the bias that we just cannot get rid of. Everything in life, everything in experimentation, everything in statistics, everything has a little bit of randomness that we just can't control. Think about um, if you are leaving home and you're trying to measure how many stoplights are red or green in between your home and school, right? Whether you bike, walk, take the bus, get driven there, drive there, right? The part that you can't control is which ones happen to be green or red at the moment in which you arrive. So it's random. And if you are picking, say, the proportion of green lights versus red lights, that's out of your control. And you might get all green lights, you might get all red lights, you might get anything in between, right? And it's not going to be representative necessarily, but you can't control that, right? It just is. As opposed to picking an inappropriate sampling method, which introduces what we call non-random sampling bias. So convenience sampling, for instance, especially if you have um, so for instance, let's say you have a media outlet or, um, okay, for example, let's say you have a favorite TikToker, right, an influencer. If they post a poll to their followers, that's not a representative sample of the opinion of everybody who uses TikTok because it's only available to those who follow this particular influencer. That is an example of a convenience sample, and it introduces non-random bias, right? Because if you, for instance, follow, I don't know, some video game streamer, I'm old, okay? Don't don't come for me. Um, you watch a video game streamer and not everyone is into that particular video game. Not everyone likes this particular person. So if they put out a poll, those responses are not random. They're not representative of everyone on TikTok because not everyone is interested in that particular topic or that particular streamer. For that reason, that introduces non-random sampling bias. So in the next video, we're going to go even further and discuss the different kinds of experimental design principles, not only for what we end up calling experiments, but also what we end up calling observational studies. And we'll discuss the differences. All right, I'll see you in the next one.